A significant find was made by paleontologists in Grand Canyon National Park, which is located in Arizona. They've discovered fossil footprints that have been remarkably preserved, which shed light on the ancient environment of the desert and the people who lived there in its earliest days. These fossilized footprints were left in this region approximately 280 million years ago during the early Permian Period by primitive tetrapods, which are animals that walk on four legs and roamed this area. Our knowledge of life in the area before the appearance of dinosaurs has been pushed back further as a result of this discovery. The fossil footprints that were discovered in the Coconino sandstone provide an insight into the behaviors and characteristics of the early tetrapods that left them. Ichnotherium is a type of trackway that has never been seen before in the Coconino sandstone or any other type of desert environment, according to the researchers who discovered these tracks. This discovery casts doubt on the widespread belief that the only animals able to endure the harsh conditions of the desert during the Permian periods were reptiles. It lends credence to the idea that these early tetrapods were already adapted to life in environments with a restricted supply of water. Due to the excellent state of the preservation of the footprints, paleontologists have been able to glean important information about the anatomy and movement patterns of these prehistoric creatures. The significance of studying fossil footprints in recreating ancient ecosystems and gaining an understanding of the evolutionary history of life on Earth is brought into sharper focus by this discovery. Paleontologists have been given a remarkable glimpse into the past thanks to the recent discovery of fossil tracks in Grand Canyon National Park. The tracks date back approximately 280 million years ago, which enables them to provide this glimpse. These footprints date back to the very beginning of the Permian Period, which is a significant amount of time before the first dinosaurs appeared on the scene. This discovery is extremely significant because it gives researchers a better understanding of the ancient ecosystem and the organisms that inhabited it before the dominance of the reptilian group. Paleontologists are able to learn a great deal about the behavior, movement, and anatomy of the creatures that left these tracks behind by carefully examining these tracks. These new discoveries shed light on a period in Earth's history when it was inhabited by a wide variety of primitive tetrapods. Tetrapods were four-legged animals that lived before the reign of the dinosaurs. It's essential for deciphering the evolutionary history of life on our planet that we have a solid understanding of the early Permian period. The tracks that were found in the Grand Canyon National Park serve a tangible evidence of an ancient world that existed a very long time before the familiar giants of the Mesozoic era took their place. These tracks were discovered in the Grand Canyon National Park. A groundbreaking find was made recently in Grand Canyon National Park when fossil footprints were found in the Coconino sandstone. These footprints are the first time that the Ichnotherium trackway has been discovered in the Coconino sandstone and in a desert setting. This trackway, which is associated with a relative of early reptiles that has been extinct for a very long time, sheds light on the evolutionary history of these very ancient creatures. The discovery of Ichnotherium fossils in the Coconino sandstone has yielded important new information regarding the behaviors and adaptations of tetrapods that lived in environments characterized by aridity. It casts doubt on the theory that the Permian period was inhabited solely by reptiles that were able to endure such harsh conditions. Paleontologists are able to examine the characteristics of these long-extinct creatures as well as how they moved by studying the trackways left behind by these animals. Scientists are able to deduce information about the size, gait, and foot anatomy of the animal that made the tracks by analyzing the shapes and patterns of the tracks. The groundbreaking discovery that was made adds a new chapter to our understanding of ancient ecosystems and the variety of life that once flourished in the arid environments of the past. The fossilized trackways that were found in Grand Canyon National Park hold an impressive distinction. They are the geologically youngest record of a particular type of fossil track that's ever been found anywhere in the world. This discovery may have important repercussions for our understanding of the evolutionary timeline and the geographic range of these ancient creatures. The tracks are among the most recent examples of this type of fossil track because their age, which is approximately 280 million years old and dates back to the early Permian period, places them in that category. Paleontologists are able to glean valuable information about the anatomy, behavior, and movement patterns of these organisms that left the imprints behind by carefully analyzing the state in which these imprints have been preserved. The fact that our knowledge of the temporal and geographical range of this particular track type has been expanded as a result of this discovery is the primary factor contributing to its significance. This highlights the importance of studying diverse fossil records from a variety of regions in order to paint a more complete picture of prehistoric life and its evolutionary trajectory. The recent finding of fossil footprints in Grand Canyon National Park calls into question long-held beliefs about the existence of life in the harsh Permian Desert. The fact that these footprints have been preserved so well demonstrates that tetrapods, not just reptiles, were able to thrive in environments with a scarcity of water. Our understanding of the ecosystems that existed in the Permian Desert and the variety of organisms that lived there has been fundamentally altered as a result of this discovery. It suggests that adaptations for arid conditions were present in other groups of ancient animals as well, and that reptiles were not the only group of ancient animals to have possessed such adaptations. Scientists are able to gain insights into the psychological and behavioral adaptations that allowed these tetrapods to cope with limited water availability by studying the fossil tracks left behind by these animals. The discovery highlights the need to reassess our assumptions about the distribution and survival strategies of prehistoric life forms and underscores the importance of understanding the complexity of ancient ecosystems. An intriguing group of extinct tetrapods known as diadectomorphs possessed characteristics of north amphibians and reptiles, and the discovery of fossil tracks in Grand Canyon National Park has provided significant new information regarding the paleobiology of diadectomorphs. These remarkably well-preserved tracks shed light on the behaviors and locomotion of these mysterious creatures, contributing to our understanding of their evolutionary history in the process. Due to the fact that their place in the vertebrate family tree has never been conclusively determined, diadectomorphs have been long one of the most intriguing topics of the world of science. Researchers are able to gather information about the anatomy and movement of ancient tetrapods by analyzing the size, shape, and arrangement of the fossil footprints. This information can be obtained by studying the fossil tracks. This new evidence questions the validity of previous hypotheses and contributes to the process of elucidating the mystery surrounding diadectomorphs. These fossilized footprints provide empirical evidence about their existence and shed light on the terrestrial activities and ecological adaptations of the extinct animals. Diadectomorphs are animals that represent a transitional group between amphibians and reptiles, so it's important for us to comprehend their paleobiology so that we can gain a more comprehensive understanding of the evolution of vertebrates. Scientists are able to gain valuable insights into the behaviors, modes of locomotion, and ecological roles of these one-of-a-kind creatures by analyzing the fossil tracks that have been discovered in Grand Canyon National Park. These creatures once roamed the ancient landscapes. The paleontological resource inventory makes it easier to pinpoint areas in which our knowledge is lacking, which in turn helps direct future research endeavors and conservation efforts. Scientists are able to reconstruct the ancient environments, track the evolutionary changes over time, and contribute to our understanding of the geological and biological history of the Earth through the process of documenting and studying the fossil record in the park. This exhaustive inventory serves as a testament to the park's commitment to scientific research, education, and preservation of its natural heritage. It helps to ensure that the valuable paleontological resources contained within Grand Canyon National Park are protected and will continue to inspire scientific discoveries for many generations to come. And that's all for this video. Subscribe if you want to watch more videos like this.